Okay, so we are going to start with the parent function, y equals x squared. What is the family for that? What's the family? Quadratic is the correct answer for the family. Quadratic. So let's go ahead and write that down. Today is all about the quadratic family. On your test and in our notes and in our review, we went over what are the key points for the quadratic, for the parent function. So that's what we're going to fill in here, the key points. Sela, do you remember what the x's start with? They go from -3, -2, -1, 0, 1, 2, 3. And Jacqueline, do you remember what the y's start with? Well, we're plugging -3 into x squared. So what's -3 squared? What's -3 times -3? I can't hear you, hon. -9? What's negative times negative? 9. So this would be +9. And then that was messy. +4, +1, 0, +1, +4, +9. So we'll have those symmetric y values. And then we go over and we plot those values. 0, 0, 1, 1, 2, 4, 3, 9. Also -1, 1, -2, 4, -3, 9. So these values, the y value is a squared of the x value. If you forget the values, you just have to multiply the number by itself. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Square roots, or squares, I mean. Now, we did that and then we did transformations with it. We haven't really talked much about this quadratic, so I'm going to talk about a couple things real fast. We'll jot some notes down. First of all, the shape or the figure itself, the graph, is called a parabola. So if I keep calling it parabola, I'm talking about that U-shaped thing. The function is a quadratic function or equation, but I might call it a parabola. And then I'm going to color code some things over here. One of the most important things that we look at, that we find and we use, especially with transformations, is our vertex. Our vertex is the point that is right in the very middle of this graph that does not have a mirror point on the other side because it's right in the middle. It's on the mirror. That's our vertex. Now, this is the parent function. Brecht, where's our vertex of this parent function? 0, 0. Okay, the next thing is something called the axis of symmetry. So the axis of symmetry is the mirror. So I look over here, the mirror is not just like a dot. The mirror is an entire line, which is why it's called the axis of symmetry. It is an entire line at which if I folded the line, both halves of that parabola would line up. Because it is a line or an axis, it's going to be an equation, which means it will have an equal sign. Does anybody know the equation of that green dashed line? X equals 0, right? That was something you needed to know for a past chapter. So we're building on things from before. X equals 0 would be our axis of symmetry. Once we start having transformations, it won't always be at x equals 0, just the parent function is. Other things that we might look for, and they aren't very exciting right now because there's no transformations, but a y-intercept. That's going to be important to us, a y-intercept. Right now, the y-intercept always is 0, comma something. Where does this graph cross the y-axis? 0, 0. And then that's already, we already have a point there, so I'll go ahead and make that blue also. And then we could also talk about x-intercept, but for this one, it's at 0, 0. So a lot of these things we don't really have information about until we start doing transformations, and then they change. Okay, what you're going to do, first of all, before you do anything, this entire chapter is about quadratics. This entire chapter is about this U-shaped guy. You should not be graphing anything else right now. What we're going to do is, this is f of x. This is f of x, x squared. That's our parent function. If you look at every single one of these examples, all of them have an f of x and then some sort of transformation. So the first thing that we're going to do is we're going to all plot the f of x. So I'm going to do it with you to begin with, and then I'm going to stop the video while you do a lot of it on your own. But the parent function, the points are on yours above if you need it, but I'm just going to say them like 0, 0, 1, 1, oops, 2, 4, 3, 9, because those are perfect squares. Or I go the other direction, negative 1, 1, negative 2, 4, negative 3, 9. These points are symmetric. They like mirror each other. So if you can do half of it, you can do the other half. Okay, that was number 1. We will, after you do this, fill in the information and do things. So I don't want you to graph the transformed function yet. Only want you to go through the other 21 graphs and start plotting the points for every single one of them. In doing that, you will A, know those points really well, and B, hopefully find a way to make it faster for you. So I'm not telling you patterns right now. I want you to figure out a pattern of how you can make it faster. You got to plot that on every single graph. Okay, go ahead and do that. Okay, as I was walking around and seeing how you were doing it, there were some of you, because we were doing the exact same graph over and over and over again, you were just kind of like memorizing where they were. You weren't thinking about points at all. You were just memorized where they were on the graph. Is that some people in here? I could tell when you were plotting them, you were just like, oh, I know it's here in the middle, and I know it goes there. I know these are here. So you were just memorized. Okay. So that actually will be the least helpful to you, just so you know. It's fine to get through the parent function, totally fine. Because I did give you all the same shape of coordinate plane. But as soon as I give you a coordinate plane that doesn't look like this 10 to negative 10 thing, then you might be in trouble. I saw some of you that were thinking what I said every single time, and you were going 0, 0, out 1, up 1. Like I could see your finger going out 2, up 4, out 3, up 9. And then the other side as well. I saw the exact same thing. I saw some of you do that, but you went like 0, 0, out 1, up 1, and then you did the mirror 1 right away. And you did out 2, up 4, and then you did the mirror right away. Out 3, up 9, you did the mirror right away. Either of those two? Anybody doing that stuff? Because I could see it. Okay. Jackson, I'm going to pick on you because I think you were doing a different way, which is a good way. It's a good way. But I think you were doing a different way than the way I just mentioned. Like you were going here, and then you were going to 1, 1, and then where were you going?
I was going up 3.
He noticed that from the 1, if you go out 1 more, it's a 3 difference from that height. And then from there, it was like a 5 difference. So he was looking at the wide differences being 1, 3, 5. And that is a real pattern for quadratics. The next height difference would be a 7. That's way off the graph, but the next height difference would be a 7. And 1, 3, 5, and 7 are odd numbers in order. So that is another good way of doing it. I feel like any of those ways is going to help you do it quicker. And in mathematics, the faster we can do it, the easier we can do it, we like it better, right? So now what we're going to do is go through a couple of these together. The rest of it you'll do on your own. So I'm first going to go over number 1, and so I can explain what those letters mean. So we'll start with number 1. So if you're still filling out your parent function, you're going to have to pause on that and do it later. We're going to start at number 1. We're going to look at g of x is equal to f of x plus 3. Now, I told you at the beginning, f of x is always the same thing for this entire worksheet. What's f of x? It's always y, but what is it equal to? Huh? F of x is, it's x squared. It's x squared up here, way up here. Doop, 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 doop. Here it is. F of x is x squared. So this whole worksheet, f of x is the function x squared. So the E stands for equation. So we write x squared plus 3. So in the E part, that's where we're actually writing the equation. T is, in words, the transformation. So Carson, what does f of x plus 3 tell us to do to the graph? Okay, so either of those answers, one of them is correct. I don't like the go part. Can you talk to me in like more mathematical, mature mathematical language? What, huh? Translate up 3, yeah. Thank you. So we're translating up 3 units. The majority of these, you will be able to just look at the graph and move it according to the words. These should be easy ones. So I'm going to take this is how I'm going to do it. I'm going to take my vertex and I'm going to go up 3 units. Then, because I learned a pattern of where all my points go, I'm going to apply that pattern at my new vertex. So if you're going out 1, up 1, go from your new vertex. Out 2, up 4, go from your new vertex. Or what Jackson was doing, I didn't ask, was anybody else doing the up 3, up 5? Okay, good. If you're doing that pattern, then you're doing it from your new vertex. And 9, out 3, up 9, or up 5, that's off the graph, but it's not so far that I couldn't graph it. So instead of me literally translating each point 3, I moved the important vertex and then filled my pattern in. Because I'm going to make my life easier. I don't want to move 7 points. I'm going to move 1 and draw my parabola. Okay? D stands for, anybody know? Domain. What is our domain? All real numbers. If you haven't learned it yet, it's from left to right, and this graph goes all the way to the left, all the way to the right because of the arrows. Range. Y is greater than or equal to 3. So the range is how far down to how far up. When you look at this graph, it only goes down to 3, and then it goes right back up again. And I'm answering these for the blue one, by the way, not the parent function. Parent function is how I got the blue one. All right, then we write the vertex. So you should be able to look at the graph and figure it out. What's the vertex? 0, 3. Now the axis of symmetry, you don't have to draw it. You can if you want. I'll draw it right now. The axis of symmetry is that line that is right in the middle. So I need that line, the axis of symmetry. What line is that? X equals 0. And then the y-intercept of the blue one is 0, 3. Sometimes the vertex and the y-intercept are the same. Sometimes they are not. Okay? So the stuff we've been doing, we're doing again, but we're only focusing on quadratics and maybe learning a couple new things. Let's skip ahead to number 5. So number 5 is the next one we're going to do together. So we have a of x equals f of x plus 3. So if I have f of x plus 3, where's the x plus 3 going? When we have something like this, it means replace x with parenthesis x plus 3. So that x plus 3 is going inside of the function. And this function is a squared function. So my a of x equation will be x plus 3 squared. It replaced the x squared with the parenthesis x plus 3 squared. See the squared's on the outside? And on the inside is the x plus 3. Got it? Translating where, or transformation where, this one is translated. Amy, do you know? Yes, translate 3 units left. So I'm not going to do every single ordered pair. I mean, I am, but I'm not going to count. I'm going to count one of them, 1, 2, 3, the vertex, and then I'm going to use my pattern that I developed. So 1, 1, 2, 4, 3, 9, or whatever pattern you are using. And because we're using Kami right now, if your graph's ugly, just like erase it and try again. Sometimes it is really ugly when you have like it not, the back of the computer not supported. So if you make it flat like paper, or if you put something in between to make it easier for yourself. I have to hold it. Okay. Domain. All real numbers. I wonder if that's the same always. Range. Yanzi, what do you think the range is? Yeah, good. Y is greater than or equal to 0. Vertex, Gavin. -3, is correct. Now, a challenge. Hannah. Axis of symmetry.
The axis of symmetry would be x equals -3.
Very good. It's that point right in the middle. X equals -3. It passes through the vertex. It passes through the vertex. And the y-intercept. Jack, what's y-intercept?
0, 9.
Very good. And you got that by
You just look on my graph.
looking at the graph, and we had a dot there, huh?
Yeah.
Yeah, good. All right, we're going to skip ahead to number 12. Okay, I'm going to tell you 12. There's only one like number 12 on here. And we're going to go over it together because you would get it wrong if you did it by hand right now. If I said, you try number 12, you get it wrong. Because number 12, we haven't done anything like this one so far this year. I purposely never gave you any kinds like this one because it's got a trick to it. So I'm basically teaching you how to do something like number 12. There won't be any on your assignment when you do it after number 12. We'll just have to revisit it later. Okay, so the reason why number 12 is different is we have a reflection, a horizontal reflection, and we have a horizontal translation. We have two horizontal transformations. If we have two horizontal transformations, they have to be separated with an extra parenthesis. Must separate with an extra parenthesis. And we do that by, and this is a phrase that I made up, but maybe you've heard it before, but I made it up. Other people make it up too. Undistributing. I'll tell you the actual vocabulary word is not undistributing. I'll write the vocabulary word in a second. But this is how you're going to know it right now, because I know you know how to distribute. Yeah? You know how to distribute. We just had to do it for our test. You guys know how to do that. So we're going to undistribute. So what undistributing is really called is called factoring. So we're going to factor out the -1. So that's what's in front of the x. It just looks like a negative sign, but I know it's a -1. So we're going to factor out the -1. We're going to undistribute it. So my R of x should really look like R of x equals f of negative sign or -1 extra parenthesis. So if I take out the negative from the -x, I have x left over. If I take out the negative from -3, what do I got? +3. Then I have 2 parentheses. So the negative sign and the x plus 3 have to be in different parentheses. If you just put parentheses in and you don't mathematically undistribute it, you will get the answer wrong, because you can see that the 3 changed to a -3, or sorry, the -3 changed to a +3. Okay, so for here, our equation is going to be R of x. And then this is all on the inside. So I do inside negative, inside x plus 3, close parenthesis squared. So that would be my equation. So all I did was replace x squared with that big parenthesis squared. Now we're going to describe our transformations. It doesn't have to be in a specific order, but I just always go left to right, the way we read. I come to a negative first. That's a reflection, but where? Reflection in the you got a 50-50. Is x-axis or y-axis? Okay, it is the y-axis because it is horizontal. If I reflect something horizontally, back and forth, back and forth, back and forth, that goes over a y-axis. And then after that, translate 3 units where? So the reason why I had to factor it is because I will only get it correct if I look at this one. If I look at the original, it's not going to be correct. So I look at the factored one. Which direction are we translating? Opposite of +3 is? I can't hear you guys. Oh, left. Yes, negative. So we're going to go over here. We're going to translate left 3 units. And it's going to, sorry, I got to stand up for this. We're going to first reflect in the y-axis. So here's my parabola. I got to be human parabola here. If I reflect in the y-axis, that's left and right. So if I reflect in the y-axis, what happens to my parabola? It's exactly the same place. And then we're going to move to the left 3. So I already did the reflection. You can't tell because it looks exactly the same. Go to the left 3. And then apply that pattern. I'm not going to fill out the rest of this one because it looks exactly like one we've already done. So you guys can fill the rest of that part out. How much time do I have? Are we till 20? Yeah, we don't have much time. With these multiplication ones, I highly recommend, and I have number 13 done on my notes, which I've already posted on your module. I have number 13 done. I used a table for all the ones that I had to multiply by a number that wasn't a negative. I used a table. So the way that we were doing it last time, last chapter. So for this one, I would multiply all of my y's by 3. So that's how I'm getting my parent function, or not parent function, my new function, my t of x for this one. Let's see, t of x would be 3x squared. That's how I'm going to get all the points for that one, is multiplying all the y's by 3. And then what if we have it on the inside? If it's on the inside, I'm going to multiply the x's, but what would I multiply the x's by for this one? 1/3. So all those same rules that we learned are still applying. We're just only doing quadratics for this one. So this assignment is due Friday night, 11:59 p.m. You should have a lot of it done, if not all of it done, by tomorrow, so that you could ask questions. We've already done some of it together. You've already done your parent function for all of them. They will go fast. I will post an answer key so you can check your answers. They need to be accurate. Don't just copy my answer key and make U's. You need to be able to plot those points.